What we did for this problem is first the P and the Q, right? We figured out all of the factors of this, the 24, and those are P. We figured out all of the factors of this number 1, and those are the Q's. And now you take the combinations of all the P's over all the Q's, and this is what I have. What this is a list of numbers that might be zeros of that polynomial, okay? What the next step is you're supposed to go down that list. So you have positive 1, negative 1, positive 2, negative 2. And you're supposed to do synthetic division with every single one until you find a number that gives you 0 for this denominator, for this remainder. Okay? You can do the long division, but it doesn't, it's longer, and it doesn't lend itself to this factoring as easily as this does. But yes, you can, absolutely.
So you can't just long and choose.
Make your life a little bit easier, okay? Rather than having to try each and every single one of those P's and Q's, right? What we did is we plugged that number, that polynomial into the calculator and graphed it. Okay, okay, is this it?
Yeah.
Okay, so you see the zeros here? All right. I can visually see that there is a 0 at x equals 4. So that's why I skipped all those and I just said, okay, let me just put in the 4. Could I have tried negative 2 and negative 3? Of course, I just chose for no reason whatsoever that number 4. Maybe because it was positive. I don't know. Okay, now we're here. I'm still nowhere near having factored this whole thing out, right? Because now I have, so this is where we had stopped last time. Now I have this that I need to factor, okay? So you know what I do for that? The whole thing all over again. So now,
keep going if you know it's a 0.
I need to factor every single one. So here's what I do. Here's what I'm going to do. What's P over Q for this one?
1, 2.
Plus or minus 1. So now it's the 6. It's a lot less, right? 1, 2, 3, and 6, plus or minus. And P over Q is actually the same because Q is just plus or minus 1. So now I need to do this. Again, the 1 in front of the x4 gives you the Q. So now, again, technically, I should check every single one. Plus 1, minus 1, plus 2, minus 2, plus 3, minus 3. Now, all these are still that main polynomial, right? So when you go to the graph, what's another 0 here? Negative 2. You don't have to replug that whole thing because this is a factor of that big one. So whatever is a 0 of this is also a 0 of that.
So why can't you use 4 of that?
Because you already used 4. You can't reuse them. Okay. So now let's do negative 2 for this one. And I'm going to color code it. So I'm just doing the red for this. 1, 5. No, he chose negative 2. You could have done negative 3. Aviv chose negative 2. You could have done negative 3, but not 4 because I already used 4.
And then you're just going to do it again,
Right, so this is going to give me a 3, negative 6, 1, negative 2, 3, negative 6, 0. Okay, now,
Where do you get those 1, 5, 7, 5?
those are the coefficients of this. Okay, now, the purple part, before I had x minus 4. Now, what do I have? What does that negative 2 give me? X plus 2. And the depressed polynomial here is x cubed It's x minus that number. So x minus negative 2 is x plus 2. So x cubed plus 3x squared plus x plus 3. Okay. Now I need to factor that further. What color? Blue. Okay. You can do this in two ways. You can either, this particular one, it happens to be that it's possible to factor by grouping. If you don't remember what that was, you could do it the same way. So let's just keep doing it the same way and then I'll show you the other way. So what's P over Q for this one? Plus or minus 1, plus or minus 3, right? What's another 0 from that graph? Negative 3. So I'm going to do negative 3. What numbers go here? 1, 3, 1, 3. 1, negative 3, 0. 0. Wait, 1 here. Negative 3, 0. Okay? Now, I have that purple, x minus 4. I have that red, x plus 2. Yes, you have to carry them with you at each step. Then I have x plus 3. And here, that 0 is the remainder. So here, x squared plus 0 plus 1. Okay? So finally, that's my k of x. Now, once you have an x squared, a quadratic, you don't have to do this p over q anymore because you know how to factor quadratic equations. Now, it just so happens that when you have x squared plus a number, that cannot be factored. When it's just x squared plus a number, that cannot be factored. So you cannot reduce that any further. So for now, we're going to stop here. Let's go back and remind ourselves what this part A asked us to do. It said to write kx as the product of linear factors. So what are linear factors? X minus 4, x plus 2, x plus 3. Those are where the x has an exponent of 1. So linear and irreducible quadratic. That's this x squared plus 1. Okay, so basically what it's saying is factor until you can't factor anymore, which is what we did, right? Okay, now for part B, it says now list all the zeros of kx. So let's see what kx is. Yeah.
Not exactly sure if you answered it, but what about all the other numbers that we had, like positive 2 and
In that list?
yeah.
Okay, not all of them are going to be zeros. However, all of the real rational zeros that you get are going to be included in that list. Okay? So all of
They're gonna
all
be
the zeros are going to be in there, but it's not like all of these are going to be zeros.
But how do we didn't try all of them, so could there still be more?
No, because the graph doesn't show you more. Okay? Yeah, yes. Yes, there are 5 total, but they're not all real zeros. So, yeah, so we're going to continue now. So we set each one of these equal to 0 now. X minus 4 equals 0. This equals 0. This equals 0. And this equals 0. So from the first one, I get x equals what? 4. From the second one? From the third one? And here, x squared equals minus 1. I take a square root. X equals plus or minus the square root of negative 1. So from your algebra days, whether algebra 2 or intermediate, what's the square root of minus 1? It's I, right? Do you guys remember the imaginary number I? Okay. So there is an imaginary number, as if real numbers weren't enough. There is an imaginary number called I, okay? And it's the square root of minus 1. So whenever you see the square root of minus 1, you just say I. Okay? And it's imaginary, meaning it doesn't show up in any of your graphs. So now what are the zeros of this? 1, 2, 3. How many are here? Plus I, minus I. So that's 2 for a total of 5, right? And remember, my initial degree was x to the 5, so there are supposed to be 5 zeros. Okay? That's all we do. We're done with that problem. Okay? All the ones that I've circled. 4, x equals 4, negative 2, negative 3, and plus or minus I. Okay? So since some of you don't remember the whole imaginary number business, let's do a little bit of a review. Okay? Whoops. Okay. So anytime you see the square root of minus 1, that's an I. Okay? Now, what would the square root of 4 be? 2. And until now, when you saw the square root of negative 4, you would say, can't do the square root of a negative number. But now, right, now what happens is this negative comes out as an I, and all you have is root 4 left, so it would be 2I. Okay? So along the same lines, what if you have the square root of negative 25? How much would that be? Right? 5I. Now, what if you have the square root of, negative 7? I comes out, I root 7, right? Because you can't simplify the 7. Now, what if you have this? 3I plus 2I. How much does that make? 5I. That's it, just 5I. Okay? What if you have 5I times another I? It's 5I squared. But what's I squared? Not 1. I squared is negative 1. So this would be 5 times negative 1, which is negative 5. Okay? Because we remember? Okay. You will. It's the first one that leaves you because it's so new in algebra. Okay, so now taking that knowledge back with us. Here it says to write a polynomial function. So basically what this is doing is, from now until now we were given the function and it asked, okay, find the zeros. Now it's giving you the zeros. So it's giving you this blue stuff and you have to go back and find this. You have to find this. Okay? All right. So 2 things here. Imaginary numbers always come in pairs. Okay? So if you have an I, you also have, you also have a negative I. Okay? So now your zeros are negative 3, I, negative I. So stretching that exercise, if you have 2 plus 3I, what do you also have? 2 minus 3I. Okay, so you take the imaginary and you flip the sign. So if 5 plus 7I is a solution, what else is a solution? 5 minus 7I. If 8 minus 2I is a solution, what else? 8 plus 2I. Okay? All right. Now, you remember here, right here, whatever number you have, right, you get a factor, so x minus that number. We're going to do the same thing here. So if I have minus 3, I'm going to do x minus negative 3. And then x minus I, x minus negative I. All right. Now, the first one gives me x plus 3. Second one, x minus I. And what's the third one? X plus I. Okay, now I need to multiply all this. Okay? So what I do is this. X plus 3, leave it off to the side for a minute. Do the ones with the i's together. So I'm just going to multiply this. Okay? Can we do first, outer, inner, last for this? I know there's a shortcut, but let's do that other one. Okay, so first terms give you what? X squared. All right, so that's the first terms here. What do the outer terms give you? The outer terms plus xi. The inner terms minus xi. And then the last terms, negative I squared. Yes, we're going to change it now. So this is x minus 3, x squared. What happens to the middle here? These go away, huh?
Why is it x minus 3 instead of x plus?
Oh, plus, sorry. So here we have negative I squared. How much is that? Is it? It's negative. What's I squared? I squared is negative 1. So it'll be plus 1. So I have x plus 3, x squared plus 1. Okay? Now let's multiply that. All right. The first terms give me x cubed. Outer terms, positive x. Inner terms, 3x squared. And the last one, 3o. Okay, so in order, x cubed plus 3x squared plus x plus 3. And I call it a name of a function, f of x, h of x, g of x, whatever you want. And there you have it. You just came up with a function that when you solve, the zeros are going to be what? Negative 3 and I and negative I. Exactly. All right? Okay. Okay. Negative 1 is a 0. 2 is a 0. 2 minus I is a 0. What else is a 0? 2 plus I. All right? So, what's my function going to be? X minus negative 1. And then x minus what? X minus 2. And then, in brackets, x minus the first 0. Yes? And then x minus the second 0. Okay? Does that make sense? So I have x plus 1, x minus 2, and now I'm going to distribute this. So I have x minus 2 plus I and minus I. Okay? Now, can we multiply this one out?
We do, yeah.
Yeah, so let's do that. So it's x squared plus what? Right, plus 1x minus 2x minus 2. Okay? Now you're going to do the other one. Okay? So first, we're going to distribute the x. Okay? Everybody in the second parenthesis is going to get an x. So it'll be x squared minus 2x minus xi. Now we're going to give everybody a what? A negative 2. So it'll be negative 2x plus 4 plus 2i. Then we're going to give everybody what else? An I. So it'll be positive xi, negative 2i, minus I squared. And really the i's should go away at some point, okay? All right, so coming back here from the red, we had x squared. That gives you minus x minus 2, okay? And here, what do I have? X squared. Let's see, do the xi's go away? They do. What else goes away? Yeah, plus 2i minus 2i goes away. So I have minus 2x, that's minus 4x. Okay, this is a plus 4, and how much is that? Plus 1. Now you have to multiply again, all right? So I'm going to pause this recording for 2 minutes. You're going to multiply this out, and we're going to come back. Yeah. Okay, so first the x squared. So we get x to the 4 minus 4x cubed plus x squared, right? Then the minus x cubed plus 4x squared minus x. Then the minus 2, minus 2x squared, positive 8x minus 2. Now let's see what we can get rid of. So it's x to the 4, that doesn't have a partner. Negative 4x cubed minus another x cubed is negative 5x cubed. Positive x squared, positive 4x squared, that's 5x squared, minus 2, so that's 3x squared. And then minus x plus 8x is 7x minus 2. And call it f of x. All right? Okay, now, here's one more. What if you're given a 0 and it says to find all the other zeros? Okay? Well, if you're given a 0, what if you're given a 0 that's imaginary? All right? And you need to find all the other zeros. So take a look at this polynomial. How many total zeros should it have? 5. You're given 5i. What else do you know exists? Negative 5i. All right? And then you need to find 3 more. Okay, so what you do is synthetic substitution with the 5i and the synthetic one with the 5i, and then you're gonna see that we're not gonna be able to stop there. So 5i, I have 3 minus 5. You know what? When you're doing okay, so you're given that 5i as a solution. Right. Yes, but now you're given an imaginary one. When you're working with the imaginary ones on the outer left, leave a little bit more space because things are gonna get expanded. So it's minus 5, negative 13, negative 65, okay. Here we go. So 3 comes down. What do I multiply by? 5i, and I get 15i. Now, when you add negative 5 and the 15i, what does that give you? Negative 5 plus 15i. Oh boy. So it's just negative 5 plus 15i because you can't combine them. Now what do I have to multiply? I have to multiply 5i and negative 5 plus 15i. So, yes, so I'm gonna do it on my scratch paper here. So it's gonna be 5i times negative 5 plus 15i. How much would that be? negative 25i plus 75i squared, which is negative 75 minus 25i. So I write that here. Negative 75 plus 25i. That's what I have. They were just stuck to each other. Oh, minus here. Okay. So we're multiplying the 5i, you see the underlined in red, with the negative 5 plus 15i, and I happen to do it on my scratch paper here. Yes, it's I squared here, which becomes negative. Okay, now I'm going to multiply, now I'm going to add here. Negative 13 minus 15 is negative 88 minus 25i. Now I'm going to multiply that. So 5i times negative 88 minus 25i. So how much is that? Negative 440i minus 125i squared. So how much is that? Positive what? Positive 125 minus 440i. Yes. Now, if I add negative 65 plus 125, what does that give me? Positive 60 minus 440i. Okay, now what am I going to multiply? Times 5i, right? So 5i, 60 minus 440i.
It's just so repetitive.
It is repetitive. So here we get minus 2,200 I squared, positive 2,200 plus 300i. Okay, so this is 300i, and when you multiply, you get 1,500i squared, which is negative 1,500, and you get 0. Yeah. It went away because it was 1,500i squared, which is negative 1,500. Now, what else was a 0? So 5i is a 0 of this. What else is a 0? Negative 5i. So now guess what? You have to do it again. But oh my God, this one really is cool. Watch. So look, you do negative 5i, but you do it with the coefficients that you got here. So the 3 and the negative 5 plus 15i, negative 88 minus 25i. You have no idea what's going to happen. Watch.
It's going to be the equation.
So look, 3 comes down. And now what do we get? Now what do we get? Negative 15i. And when you add, what do you get?
Oh my God.
Oh my. It's the same
You get negative 5. It's not the same equation, but it's an equation. So now when you multiply 25i, what do you get? Negative 88. Now when you multiply, what do you get? It's 440i. So you get 60. And then negative 5, well, you need to get these correct ones, right? Like these coefficients down here. So now you get negative 300i And look, it's 0. Okay? Yes.
So is that it?
Well, now, look. From up here, we get x minus 5i. From here, I get x plus 5i. What do I get here? 3x what? 3x to the... Okay, so it was 5. This made it 4. This made it 3. It's 3. Okay? And now you just have to factor that blue part. Okay? Can we do P over Q for that blue part? I guess we have to now, right? Okay, so P plus or minus 1, 2, 3, 4, 5, 6, oh my, not 8, not 9, 10,
12, not 13.
15, and then 20, and 30, and 60. And Q is plus or minus 1 and 3. So it's that whole thing, okay? Now, when I... Huh? Okay, well, you should show the P over Q to show your work. And now, yeah, now we're going to plug it in. 3x cubed minus 5x squared minus 88x plus 60. Okay, where is there a 0? It looks like there's one at -5 and +5 as well. Is it 1, 2, 3, 4, 5? 6, right? Is it 6? So 1, 2, 3, 4, 5, 6. Why don't we just work with that positive one? 6. So here we have 6. And then I have 3 minus 5 minus 88, 60, 18, 13. What's 6 times 13 these days? 78, you're right. -10, -60. Okay, so x minus 5i, x plus 5i, and then I have x minus 6, 3x squared, plus 13x minus 10. Once I have a quadratic equation, I could just factor it, okay? So how do we factor this thing?
Are all problems this long? Like,
This is one of the longer ones. So I went over I went into the homework set and I chose the longer one to do here so you could do the shorter counterpart yourself. Okay, so how can I factor this one? So let me show you this quick, cute little way. You either have to do guess and check here, right? 3x and x, and then check, and then da-da-da-da-da. Let me show you this cute little way of doing it. Okay? Simpler. Okay, let's multiply. Okay? So here I'm going to get rid of that 3 in the front, and I'll make that x squared plus 13x minus 30, right? Now this you could factor easier because there is no coefficient in the beginning. So what two numbers multiply to 30, -30, and add to 3? Add to positive 13. Could it be 15 and 2 maybe?
Oh, yeah.
Somebody has been listening the whole time. It was the Russians when I said communism. When I said communism, they started listening. Okay. So, right?
wait, is that like you do the X thing?
Almost, yeah. I hate the X thing. Oh my God, all my
Yeah, I
people hate the X thing.
love
So now, you know how I had taken out a 3? Now I put the, look, I put the 3 back. Okay? And now look, is there anything in common from here? A 3. So when I divide by 3, x plus 5 and 3x minus 2. So,
And that's your answer?
yep.
Oh my god.
What? That's the
It
No,
took us
it should be
all of
one
that
negative one
to
false.
get that.
Can you give us one of these, and we'll make it look
Yeah, honestly, that's fair.
There's so many things that
It's
can go wrong in
joking,
this
you
problem.
Okay, yes. Yes to all. So,
Yes, or close with this.
And we have no.
I want all of these completed for, I've already assigned the first 3, and that leaves 4.
Wait, when is it
Okay.
due?
I want, what day is it today? Monday, so Wednesday.
Wait, do we
Oh.
have class Friday?
Yes.
I'm not sure.
Okay, that's a totally, okay, so listen.
I'm the average.
I want all of those due Wednesday.